nomenclature of alkanes. So what of if we have something like this? Okay, what of if we have something like this and we are asked to name this compound? So how are we going to name this compound? Where are we going to start in the nomenclature of this compound? What are we going to do in order for us to name this compound very well, in order to avoid mistake? So the first thing you have to do for me is first identify the longest continuous chain, which is the parent chain. What is the unbranched chain there? So my longest chain, we're going to see how we're going to count our longest chain. So let's start. So if I should count this by if I should start from here in this direction, so I have 1 2 3 4 5. So is this my longest chain? So let's start from here. Okay, let me use red. 1 2 3 4 5. You see, both of them are 5 5 5 5. If I also decide to start from here, 1 2 3 4 5, both of them are the same. 1 2 3 4. If I should count like this, I will have 4, but if I should count like this, I will have 5. So meaning that any direction that I follow, I will still end up getting the same 5. So therefore, our longest chain here, our parent chain, is what? Which compound in alkane in which the carbon atom N is equals to 5? So the compound in which N is equals to 5 is pentane. So our parent's name is pentane. So let's talk about the alkyl group now. So our problem here is now the alkyl group. So first, in naming this compound, will I start from the left or will I start from the right? So some people usually say, yeah, you start from the right. Some people usually say, yeah, you start from the left. So in naming of alkyl group, in naming of alkane, naming of organic compounds, you can definitely start from the right, you can definitely start from the left. So you can start in any direction, but the problem is, make sure in any dimension or direction you are starting from, that your compound must have, your alkyl group, your substituents must have the lowest possible number. So lowest possible number, yep. So as we go on in our future lectures, you're going to understand what I meant by your lowest possible number. So if it starts from here, 1 2 3, you see my carbon atom having the substituents is 3. So if I start from here, 1 2 3, so my carbon atom having the substituents is also what? 3. So meaning that in this compound I can definitely start from the left and I can definitely start from the right. So anywhere you start in naming this compound, you are definitely correct. So next rule we're going to look at is, I have two substituents, which is I have the ethyl and I also have what? Methyl. So since I have ethyl and I also have methyl, which one should come first? Is it methyl or ethyl? So the truth about this is, your first, you should name it in alphabetical order. So methyl and ethyl, methyl, I have methyl, I have ethyl. So which one comes first in alphabetical order? Is it the M or the E? So in alphabetical order, the first member there that comes first, the first substance that comes first is E. So E comes before M in alphabetical order. So therefore, in naming of this compound, ethyl will come before the words, the methyl. So note that. So some people is confused on how I end up having this CH2 CH3. So I'll explain how I have this CH2 CH3. So let me make some space. So in this CH2 CH3, so you know our methyl has general formula of CH3, but in our alkane we have CH4. So when I'm talking about alkyl group, I'm talking about removing of what? One hydrogen atom. So alkane, which is methane here, has CH4, while our alkyl has CH3. So reduction of one hydrogen atom will give us the corresponding alkyl group. So, and why in naming of the alkyl group, just anyone that have reduction of hydrogen atom by one. As you can see in methane, I have removal of one hydrogen atom which changes from CH4 to CH3. So instead of calling this methane, I'll now call it what? Methyl. So what about how this CH2 CH3 come from? So you know, alkyl group, which is especially ethyl has CH2 CH5. You know why? Which is ethyl, why our corresponding alkane, which is ethane, has C2H6. So since this is our alkane, which is ethane, C2H6, so our corresponding alkyl group, which is what? Ethyl, by removing ANE and putting YL, we now call it what? Ethyl, and this is what? Ethane. So I just remove this and substitute is what? YL. So this compound now is corresponding with what? The alkyl and the alkane group by removal of what? One hydrogen atom. So this compound here, which is C2H5, which is our alkyl group, which is ethyl, is the same thing as this compound CH2CH3. Wow, and this compound is this, Abi? Yep, they are the same thing. So how do we draw this compound? This is another method of drawing alkane groups. So this is the, I think this should be the staggered structure formula. So this is another method of drawing it. So don't get confused whenever you see me drawing this way. So this is the same thing as this. Let's check whether it's the same. So here I have, definitely I have two carbon atom, two. So how many total carbon atom do we have here? As you can see, I have one and I have two. The total carbon atom I have here is what? Two, as I have here two. And how many hydrogen atom is here? I have hydrogen to be what? 5, and I have here what? 5. How? I have 2 here and I have 3 here. So 2 plus 3 is equivalent to what? 5. So therefore, drawing this in this manner and drawing this in this manner are definitely the same thing. So I can now decide. Instead of drawing this in this manner, I can decide to clean this up, and I can decide to put this. We are definitely talking about the same thing. So then don't get confused whenever I'm doing all these small things. So these are just very simple. Once you understand the law, the magic, once you understand the law behind it, is very simple. Trust me when I say it's very simple in naming of alkane. Alkane is the easiest, the most simplest compound to name when you're talking about organic chemistry. So what is our compound here? So the name of this compound is, so some people decide to start from the left, some people decide to start from the right, but me, I'm deciding to start from the right in this compound. Note that you can start both direction depending like the end product, whether you're starting from left or whether you're starting from the right. The end product is to make sure that you end up having your substituent number to have the lowest possible number. Okay, so here now I have 1, I have 2, I have 3, I have 4, I have 5. So my parents chain here is what? Pentane. So since my parents chain here is pentane, what I'm going to do now is, what's the substance I have here? So I have two substances, which is methyl and ethyl. So which one comes first? Ethyl. So ethyl, so the name of this compound will be ethyl. But how I'm going to name it? Will I just write ethyl? No, you're not going to just write ethyl. You're going to indicate the number in which this ethyl is. Why are we indicating the number where ethyl can be located? Because if you write ethyl, so if you ask me to draw ethyl methyl pentane, I can easily go and draw for you ethyl methyl pentane, but it will not be like as arranged as this one, as you can see here, because if you just write ethyl, you have not indicated the particular substituent, the particular carbon in which this ethyl is. So if you just write ethyl methyl, you are wrong, because you didn't indicate the particular carbon in the pentane or in the parent chain in which these substituents are. So when you are writing, you're expected to write the substituent in which these parent chain are located. So, and a substituent, also note that a substituent is not found at the end product. So the substituent is always found at the middle. Like, what I mean is, you can never find a substituent in this carbon atom or in this carbon atom, because whenever you find substituents there, they are definitely going to form the parent chain. Don't worry. If you don't understand, don't worry. As we proceed, I will explain what I mean. So first, let's name this compound. So in naming this compound, now we have this ethyl is in 3. So I'll write 3-ethyl, 3-methyl, what? Pentane. So the secret again behind it is, anywhere you see number alphabets, separate it with hyphen. Now let's check something. Here there is a number and here there is an alphabet. So I just went straight to the point and separate it with hyphen. There is number and there is alphabet. So I'll just keep on separating it with. But whenever you see number, you are going to just separate it with a comma sign. But whenever you see alphabet, you are not expected to separate it with any sign. As you can see here, I didn't separate this with any sign. So there should be no space there. So this should be clustered pentane. So there is no space there. So you see, I didn't separate these two words. I didn't separate it because there is alphabet. Whenever you see number, alphabets, separate it with hyphen. But whenever you see number, separate it with a comma sign. But whenever you see alphabet, don't separate it with any sign. They are just meant to be together.